That is so that we can get the recording. After the presentation is over, you're going to be emailed a survey, and there's going to be a link to that recording in that email as well. So, like I said, everyone is on mute just so we can get a good recording. If you do have any questions throughout the presentation, please feel free to use the chat feature on the GoToWebinar application, and we can get those answered throughout the presentation at the end, or if there's not time, we can get those answered through email. Today's presenter is Alan Harding. Alan is a 33-year veteran in the lubrication field and is certified as an automatic lubrication specialist. He has experience in designing and installing fully automated lubrication systems in over 1,500 applications. Alan also holds several certifications and specializes in maintenance and reliability program development and training for major companies. Currently, he's the technical consultant for Hydrotex Lubricants, a manufacturer and distributor of high-performance lubricant and fuel improver solutions. Alan, are you there?
I'm here.
All right, how about you take over?
Okay. I appreciate everybody being here today, and one of the things that we look at is why would you want to determine historic lubrication costs and usages? And the fact is, in 33 years, I have run into only a handful of companies that really understand their lubricant cost, how they spend, and what they spend on, and then the related cost of downtime and reliability issues due to either under-lubrication or over-lubrication. So we'll talk a little bit about that today, and the reason that it's important to understand your current lubrication cost and the usages, because it's so confusing in our industry, in the lubricant industry, and in manufacturing and in vehicles, as to what we should be using and how it's used. So we'll get started. We're going to move to slide number 2. We had a little glitch this morning in our computer system, so we're going to do this the hard way. If you look at the cartoon, the reason that's in there is how do we calculate the amount of lubricants a facility uses? And it gets more and more difficult as we have individuals who have not been trained on lubrication technologies and processes. But as you move forward in your organizations, this is a very key opportunity for you to get control over a 1% spend or less out of your entire maintenance budget and or your entire operational budget. That's pretty historic on the cost ratio of 1% of budget. But it's how it's spent, where it's spent, and knowing when I'm going to spend it is important. So if you look at slide number 3, again, most operations buy and use lubricants and are concerned more about price per gallon when they really should be about the cost of their operation. The majority of facility management does not know how much they use or how much they really spend on lubricants, because everyone tracks cost per pound or cost per tube or cost per case or cost per gallon. Nor do they really know how much lubricant they should be using. And then it's important to have a good understanding of which lubricant, how much should be used, and then the overall cost of lubricating. Just putting in a couple of ounces of grease is not the total cost of lubricating that bearing. Slide number 4. Here's a failure chart. SKF notes that about 75% of all bearing failures are due to lubrication issues. Proper lubrication is essential to any trouble-free operation. But there are 5 R's of lubrication. It's the right lubricant, the right amount, at the right time, at the right point, with the right method. We used to have another one called the right attitude, and that's important also. Lincoln Industrial, which has about 85% of all the automatic lubrication systems installed throughout the United States, talks about a 10-year study and noted that 10% of all bearings in a plant will fail annually due to age, installation practices, and lubrication issues. Gearbox failure charts note similar issues in percentages. So if you have a plant with 2,000 bearings and 200 of those fail, and even if just 10% of that, 20 bearings, fail because of lubrication issues, and it costs 2 hours of downtime at $2,000, the return on investment of proper lubrication is quite easy to do. Move to the next slide. The maintenance facts are grease is grease and oil is oil. That's what everyone in the world thinks, and it is the farthest thing from the truth. There's a tremendous amount of science, engineering, etc. that goes into the development of both greases and oils, especially for the application, because everything is application specific. If a little bit works, then a whole lot more will work a whole lot better. I have heard that throughout my 33 years, just put more grease or add more oil or top it off. I've literally stood in a major plant and watched a 55 gallon gearbox blow out oil because they filled it all the way to the top of the fill tube. And it overheated, and no one paid any attention. And the temperature of the bearing went up roughly to 198 degrees, and it should have been running at around 100. So those are the issues that can happen. Bearings fail because the grease is bad. How do you know? Most greases age out over about a 2-year period. You need to throw them away or dispose of them properly. But is the grease bad, or is it the wrong grease? Maybe you didn't put enough in. Gearboxes leak because the oil is bad. Well, that does happen sometimes. The oil ages out. I was in a plant the other day that had 4 drums of ISO 46 oil sitting there, had been there for 4 years. They didn't know where it went. So when we figured out that the particular piece of equipment that used that oil was gone, well, what do you do with oil that's been sitting for 4 years? Gearboxes leak because of heat. The seals fail. Is that the oil's fault? Maybe, maybe not. Maybe the oil wasn't properly looked at for seal compatibility. This grease is as good as the grease I use on the farm or in my last plant. Unfortunately, we don't get most of our mechanics to go to a lubrication study group or have them go to a program where lubrication is taught for 3 or 4 days and how it's used and why it's used. And again, I came off an old farm in Iowa, and one of the things my grandfather taught us was, here's the grease, use a lot of it. Okay. But when I got into the reliability processes over the last 33 years and looked at reliability from the key of running plants, you find out quickly that the grease I used before is not the grease my grandfather used. There's a lot of good science goes into what's happening today. Another one is, I've been greasing for 40 years. There isn't anything you can tell me to make me change my mind. I actually had a maintenance superintendent explain that to me, and I explained back to him that that's probably true, so who do I talk to who will change their mind? Heard any others in your own plants or your own facilities? Move to the next slide. Knowing how much lubricant should be used is important, and understanding why using too much or too little costs money. The other side of this is knowing which lubricant to use is just as important. If I use the wrong lubricant, it costs me a lot of money, and people don't realize that. Move to slide 7. So how do you determine the type of or the amount of lubricants a facility will use? Well, let's start by understanding what type of lubricants need to be used first. One of the things you want to do is a lubrication survey. It's designed to help identify all the different lubricants used in the facility and provide correct recommendations for greases and oils. So you go out to your lubrication room, you copy down all the names and numbers, you put them on an Excel spreadsheet, and that's what you've been using. And I really haven't had any major problems except I'm losing 5 to 10 bearings, or I lost a big gearbox, or whatever that issue is. Nobody relates it to a study of, do I have the right lubricant? So now that I have a whole bunch of lubricants listed out, does this mean the current lubricant used are the right lubricants? The answer to that is maybe not. So how to get an understanding of the lubricants currently used? You go back and you look at what the OEM recommendations are for your equipment. Which lubricants can be recommended and used correctly? Have your lubricant supplier get involved in this. That's what you pay them for. If they don't understand how to do this, then you may need to look at somebody else who has a better concept of what you need as far as reliability, training, etc. And then how do you reduce the risk? You know, you're always looking at cross-contamination issues. I was at a plant 2 weeks ago, talking to them, and one of the things they had was 2 greases. They were both lithium complex. Well, one was high temp. Well, what was high temp? Well, our application is only 180 degrees. That may not be high temp. And the grease dropping point only ran out at about 130 degrees. So they introduced a new grease for their motors because they had a new motor come in and using a polyurea. They'd been using the lithium before. The motors were older. Well, the first thing that happened is they ended up starting having problems with bearings, bearing failure. And we went to look. We did a study. They were using the polyurea because it looked like a better grease. So again, things happen. You need to be able to label equipment, make sure that everything is understood on your work orders through your CMMS program. Slide number 8. Okay, I use the recommendations to review from the OEM to review the amount of lubricants, and it's given to me in shots, grams, ounces, gallons, and then I compare the current process I'm using in light of the application. So for example, an OEM calls for a lithium grease, NLIG number 1, added 2 shots per week. So the questions are, is the current grease in use the right grease? And how much is 2 shots from a volumetric standpoint in your grease gun? Grease guns put out different volumes. You need to calibrate your grease guns and understand. And 2 shots, then what you're going to do is you're going to measure that amount of grease you put out on a postal scale, and it'll give you the amount of grams, and you can convert that to ounces or whatever that might be. But 2 shots could be a lot, it could be a little. How many different greases is the facility using? And how many different greases does the local lubricant distributor have available to sell? Again, you may ask for a particular grease, say a lithium or a number 2 or number 1, and it doesn't really meet the OEM requirement because the base oil may not have enough ISO grade in it or thickens to carry the load, or maybe it's too high speed or too slow. Maybe you need a moly base, something of that nature. So what is the application information? I'm going to look at the load. Let's say it's medium, the environment. Have a little bit of water, chemical washdown. Maybe it's dusty. Operational temperature is about 105 degrees Fahrenheit. The bearing temperatures are 82 degrees Fahrenheit, and the speed is 1100 RPM. There are so many questions about a single application that you need to ask yourself and your team to make sure that you get what you need at the right time. So the OEM calls for 2 shots. How often? A week? A month? Well, almost every OEM manual that tells you that you put in 2 shots every week bases that on an 8-hour day. So if your facility is running 24/7, how often do you need to grease? Let's say we did choose the right grease. Again, how much is 2 shots in ounces? Well, again, it doesn't tell you. So you're guessing somewhat. That makes it hard on maintenance, makes it hard on operations. So how much grease does a bearing take considering the application? Well, the bearing manufacturer can tell you exactly how much grease should go in. They can actually calibrate how long between the relubrication. But you've got to look at this as science and mathematics as a more critical opportunity for you to grease correctly or put the oil in correctly. Slide 9. So how do you calculate grease usage or amounts for a single bearing? Well, there's a grease formula, G equals 0.005 times D times B. It's been around forever. The problem is the relubrication time. In other words, the time between adding the right amount of grease or changing of oil. It all varies by application. So how do I estimate the relubrication cycle? It takes time and knowledge in some cases. And there are lubrication calculations that can do that for you. But it does come back to your load, environment, temperature, and speeds that are important because that has to be calculated into this. Number 10, grease guns. There is a difference, and you have to ask yourself, are they calculated? Measuring the amount of grease output, again, using a postal scale, provides calibration, allows for accurate output by either cubic inches or ounces. For example, a Lincoln 1147 or 1148 clear grease gun takes 33 strokes of the lever to equate 1 ounce of grease. And the output of the grease gun is 10,000 psi. An Alomite 4015 takes 7 strokes of the lever to equal 1 ounce, and the output is at 1800 psi. So different grease guns' output or amount of lubricant depends on the model. So you need to make sure that you look at that and then make sure that on your work orders it's the number of strokes or the number of ounces, and you calibrate that, and you got to make sure, because it's so easy to under-lubricate or over-lubricate a bearing, blow a seal, ruin the bearing, costing thousands of dollars of downtime. Slide number 11. Again, here's the grease amount. For example, it's easy to walk through a plant and look at, I've got 1 ounce, 1 inch bearings, 2 inch, 4, 6, whatever that might be. You may be able to get that through your CMS program or your work order process. Or look at how many bearings you bought or what's on the shelf, for example. So let's say that you've got a 1 inch bearing is a pretty standard bearing, and you get half your bearings are 1 inch, or maybe even 75% or more. So you calculate that out, okay? And what you're doing is you're going to put 0.06 ounces. Well, the Lincoln Lube system or a grease gun puts out 0.03. This would be 2 strokes. A 3-inch bearing puts out 0.43 ounces, and a 6-inch bearing roughly 2.7 ounces. So when you're looking at what the mounting is, how they're operated, temperatures, washdowns, all those things, I may need to look at how many times I lubricate and reevaluate what my practices and maintenance are, and use the lubrication as the foundation for your reliability, because everything that moves has to be lubricated. And if I don't lubricate it and it goes down, it costs me a lot of money. Slide number 12. So when I'm estimating grease usage and cost, just again, select a common size. So if the plant has 1, 3, 5, 6, 8-inch bearings, what you're looking at is I've got 200 1-inch bearings, okay, would be about 12 ounces of grease. 400 4-inch bearings, 160 ounces. So the total use would be somewhere between 25 pounds of lubricants every lubrication cycle. So by a case of 24 14-ounce or 14-ounce tubes, how much grease have I used? Am I using the right amount? What does my purchasing cycle tell me? When do my bearings have to be greased? Do I have enough grease on hand to do that? Am I continually running short, or am I having a problem? Because in this example, you'd use 308 tubes of grease per year. This is assuming a monthly PM. Excuse me. And I can tell you from example, for 33 years, I don't see plants having 308 tubes of grease go through. And this is an actual example of a plant that I use. So when you only buy 4 cases of grease at 24 tubes or 12 or 46, you need to do the math to find out whether I'm under lubricating or over lubricating. Slide number 13. Extending grease relubrication cycles or periods is important. So I've got a conveyor belt system of 41-inch bearings, low speed, medium load, located indoors, and the bearing temperature is about 80 degrees Fahrenheit. Relubrication frequency is currently at 2 weeks. The goal is to extend the lubrication frequency to once a month. So again, I start off by making sure that whatever the grease I'm using is compatible with the OEM lubricant, whatever they requested. I select an evaluation group of bearings. I'm not just going to go out and move all my bearings from 2 weeks to 3 or 4 or 6 or 10 without doing some study. I'm going to take bearing temperatures once per week for 1 month to get a baseline for temperatures before I implement a grease process into the application. I'm going to check temperatures for 1 month after the implementation. So I'm going to switch greases and relubricate every 2 weeks for 2 months. Haven't done anything except change the grease. Greases will run a little bit. You might have an issue where you have to relubricate a few bearings here and there because they're aged. Then I take the bearing temperature every week for about a 2-month period to confirm that the bearing temperatures are within the normal baseline. Then I extend the relubrication using 3-week periods and take bearing temperatures. And then again, if the temperatures remain within the normal baseline, I extend the lubrication frequency to 4 months. There are processes to purge large bearings, but what you're looking at is a methodology to move the amount of lubrication or relubrication to an appropriate time cycle. And then what you're going to be doing is freeing up that maintenance individual or that lubricator to do other things, to make sure he's watching things. Why is temperature important? Because for every 20 degrees Fahrenheit increase in temperature above operating, the life of the lubricant in the application is cut in half. So if I've got an 80 degree Fahrenheit bearing and it goes up to 120, what do I do? I add a little grease? Do I notify maintenance, or if it's an operator doing this, do I have a process or procedure that allows me to look at my bearings, what the temperatures are, and react appropriately? Because if that bearing didn't get lubricated for that month, and I missed it for another month, and I'm tracking temperatures, and it doesn't take very long, just a handheld temperature gun, or if it's a critical piece of equipment, maybe some type of thermography process will be used. But somewhere you've got to understand where your baselines are and what's occurring, because that's part of referring back to the root cause analysis of bearing failure. Number 14. Here's a slide that pretty much gives you the bearing number, the amount of cubic inches or equivalent centimeters, and it's pretty accurate. So if you look at your bearing numbers of a 206, it takes a 0.34 cubic inches of grease. You can calculate that out into ounces. And again, these are frequently used bearing sizes. Number 15, calculating gear usage, gear oil usage for a facility. Facilities have a number of different size gearboxes. Some are large, small, some are sealed for life or non-lubricated. So what you're going to look at is determining the number of critical or large gearboxes. Review the OEM information to confirm the oil fill amount by orientation. Most gearboxes can be oriented in 7 different processes or forms. And what you'll find is the fill amounts to 2 or 3 different medium-sized gearboxes, and for small gearboxes could be less than 1 gallon and some less than a half. So if I take a gearbox and I mount it upside down, then the amount of oil I need to put in changes. I need to know that. So does my maintenance individual. It needs to go into my work order CMS program. So I can walk by and look at all the gearboxes in a plant in a matter of a couple of hours and determine just what I do have. So slide 16 looks at it and says, for example, I have 20 large gearboxes at about 30 gallons each. It gives me 600 gallons of oil. I have 100 medium gearboxes at 10 to 20 gallons each. Maybe it's 150 gallons. I have 400 small gearboxes at a half a gallon is another 200 gallons. I have 4 hydraulic tanks, another 350 gallons. And I've got a compressor that gives me another 90 gallons. Do I know what the ISO grades needed are? Does all the oil that are in these units meet the OEM requirement? Is there seal compatibility issues? What's the environment they sit in? I've got a compressor that's sitting outside in the sun or buried into a small room somewhere with airflow that's not adequate. What's occurring? Temperatures go up. What does it do when I reach 20 degrees above normal operating? The oil inside there starts to fry. Is the oil a synthetic or non-synthetic? Which lasts longer? Is it approved? Is it appropriate for what I'm doing? Do I know my change frequencies by the OEM, or am I just kind of guessing? Most plants I'm in that have overhead conveying systems don't have good change processes for those gearboxes. And those gearboxes at 30 feet above the floor are going to run 25 and 30, maybe 40 degrees hotter than their counterparts down on the conveying systems at chest level. So I need to make sure I understand through temperature tracking, et cetera, what's happening so I can make those changes of my oil appropriately and get them into my process. Do I need food grade or non-food grade oils for what I'm doing? There are questions that we're asking now because of the new changes in the law for the Food Modernization Act that actually affects individuals in the plastics and the corrugated industry. So there's a lot of things we need to understand about our usage. The only way to do that is to look at it and say, what am I doing? So let's go, for example, down to hydraulics. And I've got 350 gallons. And I look at my purchasing and I used 800 gallons last year. Well, I know I had a few leaks, but goodness gracious, what's going on? Why am I using that much? Do I have a process that shows me every month what my purchases are for my critical equipment on oils, lubricants, greases? Do I really understand what my usage is, and if it goes up significantly? Am I asking myself what's going on and why? Slide number 17. Here's an example of a bottled watering plant conveyor line, floor in the overhead. You can see that there's general conveying bearings, 250, average size 1 inch. I've got some standard gearboxes. They're small. I got 80 of them. I've got 40 gallons. I've got OEM critical equipment bearings. They're 3 inches. I've got OEM critical gearbox gallonage, 50 gallons. I've got electric motor bearings. I'm going to grease every other week. I have to use a food grade, so I selected a food grade aluminum complex NLGI number 2. And if I'm doing this over a 26-week period of just relubricating, etc., I'm going to use 182 tubes to do this. Maybe I've got an automatic system. Okay, I'm going to use an NLGI number 0 food grade aluminum complex grease. I'm going to use a couple of 5-gallon pails. And then I've got all my motors that are going to use a polyurea. So I've got about 3 tubes. That's not a lot. But if I buy a big case of grease and it sits there within an 18-month period, that polyurea grease may not be any good. So I'm looking at it. Do I change gear oils annually? The ISO would be at 220 at 60 gallons, ISO 460 for some of the gearboxes, 20 gallons, and then an ISO 680 would be 10 gallons. And then I may have some other applications. And do I want to do oil analysis? Because that's part of a good reliability practice and program. It gives you a lot of information. It may allow me to extend my drains. It may allow me to find out that I've got an issue with a specific gearbox type. Maybe I find out that that gearbox really has a problem and the oil's dying because the temperature's running too hot. Then I look and find out that I substituted a gearbox with the wrong speed ratios. It's literally eating up my gearbox and the oil can't do much to protect it. Slide 18. Okay. Let's say I'm using synthetic lubricants. Again, what's the cost? $305 for $305 per case for 5 cases. I've got my other greases by the pail. I've got my polyurea. All my oils add up to about $43,000 to do this job. And then maybe I have some compressors. Cost me $8,400. Forklift fleet, 3,600 units. I'm putting in engine oil, hydraulics, some gear oil, etc. $16,000 a year. Say I've got some big Husky PET 500 units where I'm making my preforms for my bottling units. And they've got 650 gallons of hydraulic fluid. That'd be $19,500 a year. And then I got airline oil. Maybe it's $1,500. So I really have a cost of roughly $89,000, depending on what I'm doing. Do I understand that? Do I know where my money's going and what am I protecting and how often am I doing this and do I need to do that? Then maybe, again, I move to a synthetic where instead of every year I go every 2 years or 3 years or maybe even 4 years on the hydraulic systems for my big pets. Those are my critical pieces of equipment. Maybe I can extend out the drains of the forklift engines and the hydraulics. Maybe I can extend the drain cycles on my big compressors and be protected and know when I'm going to start seeing a failure because I might have a metal count that I need to look at. Maybe my lubricant additive package is depleting sooner because of heat. Maybe I've got particle counts that I need to address because there are too many pieces of little tiny things in my oil that are affecting my hydraulic units. So there's lots of opportunities to save a lot of money if I know what I'm spending, where I'm spending it, and why am I spending it that way, and then make an educated determination on what I'm going to do next and how do I keep my equipment running for the lowest cost. Slide number 19. Forklifts, fleets, public and pupil transportation, construction, all these pieces of equipment that run around. Okay. Do you have a yard pup in your yard at your plant? Forklifts. You have pickups and cars that are associated with what you're doing. Over-the-road fleets. I've got my public and pupil transportation, carrying kids to school. A lot of construction. Okay. What is the cost of operating equipment? Again, if I've got a forklift fleet of 32 units running 7,400 hours, and that calculates out to 24/7, and I'm changing oil every 2,500 hours, the cost of the oil filters, disposal, manpower can be very significant, and most people don't even look at it that way. But I can't move anything in a fleet or in a plant with my forklift fleet if my units are down, or if I'm running them so long between oil changes and maintenance that they start to drop out, and I've got engine costs, and I've got hydraulics I got to rebuild. I've got oil all over the floor of my plant because my transmissions are cracking out. What's the cost? Well, when it's done correctly, implementing extended drains using a good oil analysis program can show a real strong ROI, can impact your operational sustainability, and it's a reliability tool. So let me ask you a question. How many people know what the true cost of owning and operating a car is? I have 2 cars. I know exactly what the cost per mile is. My wife's car is a big SUV. It costs me $1.37 per mile to operate that car. IRS returns 55 cents on the mile. So when you're looking at what's the cost of my vehicle, how often am I actually running my own car? How good am I at the maintenance of my own vehicles? Then I've got to look back as a maintenance professional and ask myself, do I really know what my operating costs are for my entire operation? And my pieces of equipment that are critical to running this plant or running my operation in construction. Slide number 20. Quick overview of fleets. And this could be a large over-the-road truck running at 80,000 miles, 40,000 mile oil changes. Well, the cost of changing one unit is $2,000 a year roughly. And I'm looking at a 50 fleet annual expenditure, I'm looking at $100,000 plus. Well, how much material do I have to carry to pay for just the lubricants, let alone everything else? Well, what if I could extend that 40,000 miles to 60,000 miles using synthetic, even a better synthetic, or whatever I'm doing? I might be able to cut my cost down to, say, 80,000. It's a $20,000 hit back into my pocket. I could use that elsewhere to pay for other things. Maybe I buy a new truck every once in a while as I expand. So there's things there that we need to look at as a maintenance professional and understand the cost of what lubricants are and what I can possibly do to reduce that cost while still keeping my equipment running well. Number 21. The question is it important for a business to know what the cost of operation is? Absolutely. We need to track out what the cost of whatever that widget is that goes out the door, or whatever the amount of product that I'm carrying on my trucks per mile. Is it important for a production plant to know what the cost per unit output is? Absolutely. How am I competitive if I don't know what the cost of my unit output is, my widget? Is it important to know what the cost of downtime is and why it's happening? Absolutely. 2 hours of downtime at $15,000 an hour, that's $1,500 an hour. and it happens 10 times a year, that just digs money right out of the pocket. Is it important for a fleet operation to know what the cost per mile of operation is? Absolutely. Is it important to know if bearing failure is due to over-lubrication, under-lubrication, mechanical issues, etc.? And then how do I correct the failures? Most plants don't use root cause analysis to even understand what the failure mechanisms could be, and most of them almost never use root cause failure analysis to find out why those bearings actually failed. They just take them off, they throw them away and put a new one on because I'm in production. I've got 20 minutes. Did I put it on right? Did I bolt it down in the correct pattern? Did I torque the bolts to the correct torque values? All those questions are important because that's going to affect what happens. Do I know what grease comes in my bearings? 85% to 90% of all bearings get lithium or lithium complex. Well, that's changing because a lot of your bearing companies are now recommending polyurea across the plant. It's not a panacea. It doesn't fix everything. But a good lubricant can really work for you if you know what you're looking at. Okay. Again, most companies do not know how much they spend on lubricants. Improper lubrication costs a lot of money. Downtime costs significant money, and what you want to do is reduce costs. So by doing a good lubrication reliability program, implementing this over time, what you find is I can help control a large percentage of my failures due to over-lubrication, under-lubrication, mis-lubrication cycles, increased temperatures where I could catch the failure early because I might be able to put some grease in and run that bearing even longer, or that gearbox because I can't get one tomorrow or tonight, or maybe for 3 or 4 months. So it's really critical to understand that a good lubrication reliability program saves you money. So I'm going to ask some questions. You can answer them, and then we can discuss those if necessary. So if you'll read that, Ashley can look at that, and if we have some answers. So a Lincoln 1147 grease gun takes how many strokes to output 1 ounce of grease? Question number 2. An Alamite 4015 grease gun takes how many strokes to output 1 ounce of grease? Question number 3. There's your formula. It gives you what? The amount of grease for the bearing, the right relubrication frequency for the bearing, what grease the bearing was shipped with, information to determine the type of grease the bearing can use. And question number 4, the last question is, the current lubricants being used are the right lubricants for the application? These are the questions you need to be asking yourself at your facility, what you're doing. So we're pretty much done with the overview of determining historic usage of lubricants and their cost. So are there any questions from the attendees?
All right, I did have one question.
Okay.
Okay, it's regarding the calculation for the amount of grease to add to a bearing. You mentioned using a postage scale to calibrate your grease guns so you get a better idea of how much is being added. Okay, so the postage scale gives you a number for mass. Do you use the density to calculate volume to mass, or how exactly do you use that?
You use the weight, calculate it back into cubic inches or ounces on the scale. Most of your postal scales are ounce related. So you get a postal scale, you get the ounces, let's say it's 2 or 3, and that gives you there, or let's say it's 0.45 ounces on the postal scale. Or if you have a scale that's in the department for quality that can be measured, it gives you a good estimate of how much grease that output is. So if you do 2 shots or 4 shots, it gives you the calculated amount that grease gun puts out. Remember, grease guns age a little bit, and that might be a little more or a little less than what you need, but it's a good indication. The other thing you can look at is almost every grease gun manufactured has a good enough technical program that you can go online and find out what the output is per stroke. There's a good way to look at it also.
I have another question.
Okay.
This one is talking about grease calibration. Most of the grease guns have meters on them. Do you agree or disagree with those meters?
Well, if you look at most grease guns that are purchased, they just come with a standardized grease output. And if I put a grease meter on the grease gun itself to meter it out, like the UE System 200 grease caddy, or the one that my brain went dead a second, hold on. A standard meter, and I can't think of the manufacturer. Most of them are fairly accurate, and I've used those and recommended them for a number of years. I like to use a grease output meter so I know exactly what I'm putting in. There's actually one from Europe, can't remember the brand name, that you put on a barcode on the bearing, you scan it, it'll tell you on the meter how much should go in. When you put the grease in, it tells you that you put that amount in or more. It calculates it, it keeps a record of that. At the end of the lube cycle, you go and you download it. It actually can tell you that you missed a bearing because you've got a barcode, etc. And that may be where you want to go on critical equipment, but it is expensive to get a good meter. Again, not found any meter that I would not recommend, and you're looking at about a $400 to $500 investment to keep some really critical equipment from having problems. So I'm a proponent of them. Again, I'm a proponent of automatic lubrication systems if they're installed correctly with the right tubing size and are maintained properly. Hope that answers the question.
Yes, excellent. Another question that came in is, can you discuss the pros and the cons for battery-powered grease guns?
Well, absolutely. I like battery-operated grease guns for a couple of reasons. It gives the opportunity for the lubricator to actually lubricate more grease points in his cycle quicker. So in other words, he can do more. They're still pretty accurate. The Lincoln system, the Lincoln grease guns that are, I think they're 18 volt or 24 volt now, are still 33 strokes for 1 ounce of grease. So you can still calibrate and use them. When they need to be plugged in pretty much every other night or whatever that system is for your usage. But I'm pretty good on them. I don't see any problem. What we do need to recognize and look out for is the amount of pressure that a grease gun can put out, whether it's a battery-operated, a lever, or hand stroke. I've seen people actually blow the seals by putting too much grease in at one time, and the pressure is important because I don't want to use that to blow the seals either. So try to use a less than 10,000 psi. It only takes 190 psi to crack the bearing. In other words, the ball and the spring to move so you can get grease in. If you get to a grease point and you can't put grease in, it doesn't mean it's full. It means you have a problem with either the grease gun and or the grease zerk. And you may want to change out and use a stainless steel grease zerk. That's been my recommendation for a long time. Hope that answers that question.
All right, I have another question. This is referring to slide 14. And the question is, does a tapered bearing make a difference in the amount of grease needed?
Oh, absolutely. Absolutely. So again, you need to look at all your bearings, the sizes, the types. what they do, but this is a pretty general characteristic. This has been around for a long time. I think you're probably pretty safe with even a tapered bearing, but you need to look at the actually what the OEM asks you to put in there. Almost every bearing company can calculate for the particular bearing design and the installation and the load environment temperature speed. So if you're having a problem with the bearing, get a hold of the bearing manufacturer. Almost every calculation that they have, SKF, NTN, all have the capability of calculating the amount for that particular design and application.
All right, and one more here. Are there any benchmarks for how much in dollars a world-class program should be spending on a per piece of rotating equipment?
I'm a member of SMRP. I've been going to a lot of programs for reliability. I've studied with SKF and NTN, and I have not found a real cost per dollar. What I have seen is the percentage of spend moves from about 1%, 1.2% of the operational budget down to about 0.6 to a half. So in essence, if you do this right, your total spend can be cut by almost 50% in a world class, but it does take a lot more time. There's also a labor increase, and so maybe even some cost of equipment to get infrared units or UE acoustic units to really look at that. And that's the important part. You need to look at the cost of becoming a world-class operation versus the cost of being a very, very good reliability program, and then look at your failure rates as you move forward. But currently, I'm not aware of anything that really gives us that process or that pricing or cost. Hope that answered the question. It's a long way around it.
All right, and I have another one here. That's all right?
You bet.
Okay. At a facility that is new and has no lubrication historical data, what would you recommend for regreasing intervals?
Okay, I would look at the on all your equipment that has a manual. I would use the manual for a review. If it doesn't give you the amount of time, which some don't, I would contact the OEM and talk to them about your applications. Again, anything that's a major dollar spend on equipment becomes part of your critical nature. So let's say it's I'm going to use a 1 to 5 scale, and 5 being the highest. Let's say it's a 4 and a 5. Those you need to make sure you really understand. And then in many cases, it'll say lubricate bearings 2 shots every month. Well, how many bearings does the piece of equipment have? And you need to make sure you know exactly how many bearings and where they're at. So you may want to use a lube mapping process as you get started on a new facility and map out for your people where each lubricant goes, how much, both grease and oil. That gives you, lube mapping gives you an opportunity to look at also setting up lube cycles in that process. General lubrication of conveyor belts, etc., most people look at once a month and down, but again, a good temperature tracking and a good synthetic grease, you might go 90 days between greasing, depending on the load environment temperature speed. New equipment, a new plant always is a little more difficult because many people think that new equipment, it's in good shape to take care of it as like I did with the old equipment, but it becomes real apparent in about a year that we didn't take care of it right, and the cost becomes excessive or jumps up. So again, I would use a lube mapping system, find out what my bearing manufacturer recommends, maybe even the individuals in the engineering department that spec'd in the equipment, and design out a good process for identifying what greases, how much, and when, because it's real critical to get off on a good footing for that kind of process. Hope that helps.
All right, that looks like all of our questions. If anybody out there has any more questions, Alan's information is on the screen now. right. So that concludes today's webinar. Alan, thank you so much for presenting that. That was extremely educational.
Well, I appreciate that, Ashley, and I appreciate everyone that attended. And if I can help, let me know. Thank you very much. Have a good day.
All right. Thank you. Have a great day, everyone.